Alright, good day class. This is Mr. Adewale, your physics teacher. Today we are in for physics again, and we are considering a very interesting topic. Please pay attention, you are going to get it, and you will so much like it. Alright, we are considering refraction at plane surfaces. Refraction at plane surfaces. Can you echo that? Can you say the same thing? Refraction at plane surfaces. What is refraction? Refraction is the change in direction of a ray of light. When a ray of light travels from one medium to another of different densities. When you are moved from, for instance, from air to glass, glass is denser than air. So when you move from air to glass, or glass to air, or air to from two different medium, one medium to another, but then the medium. Now each of them have different densities. That's refraction. The bending, the change of direction of ray of light as it travels from one medium to another of different density, that's refraction. You can see it there. Look at it now. Now you can see a ray of light is incident at this point now. So this is the surface of separation of media. At this point, as it moves from this medium to another medium, you can see it bends towards the normal. This is the normal. You can see the normal. Now the ray of light is coming this way. As it gets to the surface of separation of media, it moves towards the normal. So that is refraction. Then you can see the angle. This angle is the angle of refraction, angle of incidence. This incident ray, they refracted, and you can see it is incident. This incident ray, now a refracted ray. This is refraction now. Refract out. All right. So this is the normal. So that is it. So you have the first. This is the first medium. This is the second medium. Now let's assume, okay, if this air, this could be glass or liquid. That's liquid. That's another medium. So, and in this case, you see medium 2. The second medium is more dense, has higher density than medium 1. And what happens when ray of light move from medium, from one medium to the other with different densities? Okay, let's check that. When a ray of light moves from a less dense medium to a denser medium, like this one now, from a less dense medium to a denser medium, the ray of light bends or moves towards the normal. Please note that when a ray of light moves from a less dense medium to a denser medium, the ray of light, as it comes to the surface of separation of the media, it moves towards the normal. But if the ray of light moves from a denser medium, let's say from glass to air, now it moves away. It bends away from the normal as it crosses the surface of separation of the media. So please, it's crucial you note that. What happens, for instance, when you move from glass to air, now from a denser medium to a less dense medium, that means the ray of light will move away from the normal. But as it moves from a less dense to a denser medium, it moves towards the normal. Please note that. Now, let's now consider the laws. There are laws of refraction. So can we consider that together? All right. The laws of refraction. The laws of refraction. It says that, as you have seen in the diagram there, the incident ray, the refracted ray, and the normal at the point of incidence all lies on the same plane. We'll go back to the sketch and check it. The incident ray, the refracted ray, and the normal at the point of incidence all lies on the same plane. And the second one, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of media. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of media. All right. So this second law is very crucial. They call it it's called Snell's law, and that's refractive index, which is n equals sine I over sine r. So please note that. So that's called Snell's law. What did I say? Please, let's go back to the sketch and let's the incident ray, the refracted ray, and the normal at the point of incidence. They all lie on the same plane. So that is it. So that's the laws of refraction. You should note that. Now we are going into some applications of refractive index. How you can make use of it to solve some questions. for some calculations. So let's do that now. Refractive index formulas now. These formulas will help you solve questions when you are asked to calculate a refractive index. A refractive index is equals to real depth over apparent depth. Refractive index is sine half minimum deviation plus A. A is a refracting angle of a triangular prism. Now, for this this involves triangular prism. That's a refractive index formula in a triangular prism. Refraction can also occur in a triangular prism. That's the formula. The third one, refractiveness is 1 over sine c. C is the critical angle. And then refractiveness is what? Speed of light in air in a vacuum over the speed of light in a medium. So these formulas will help you solve questions on refractiveness. You see, in the triangular prism, dm means minimum deviation. Please note that. So let's quickly solve some questions on that now. Let's check them together now. So the questions now. Number 1, find the critical angle for light traveling from water to air. We are given the refractiveness to be 4 over 3. The second one, the speed of light in a vacuum is 3 times 10 raised to power 8 meter per second. If the refractive index of a transparent liquid is 4 over 3, then the speed of light in the liquid is, you have to calculate that. The third one, the real depth of a pond is 6 meters and its apparent depth is 4.5 meters. We have to calculate the refractive index of the water of the pond. And the fourth one, a 60 degrees prism is made of a material whose refractive index is 1.6. And to calculate number 1, the angle of minimum deviation, B, the angle of refraction of the light, and C, the angle of incidence at minimum deviation. Can we quickly do that together now? Now we have to find the critical angle. And we have the refractive. Remember, we said refractive index is 1 over sine c. This is the most applicable formula now. And we have the refractive index. We are given that to be 4 over 3. So 4 over 3 will be 1 over sine c. And we have to calculate c, critical angle. So you cross multiply. Now, do not forget that the refractive index has been given in the question. So you put it there, then we want to calculate sine c now. So when you do that, that will be 4 sine c will be 3 times 1. So 4 sine c will be 3. So sine c will be what? 3 divided by 4. So sine c will be 0.75. Then you find critical angle by finding the arc sine of 0.75. Now, the arc sine of 0.75 will be 48 degree 36 minutes. So 48 degree 36 minutes. That's the arc sine of 0.75. I hope that is clear to you. So can we please check the other side? Let's do the second one here. We're going to do the second one now. The speed of light in a vacuum is, we have been given the speed of light. So speed of light in vacuum, we have that to be what? 3 times 10 raised to power 8 meter per second. Then the speed of light in liquid is what we want to get. We don't know it. Then we are given a refractive index, N, to be 4 over 3. Then you know that one of the formula, the third one will be most appropriate now, which says the refractive index is the speed of light in air all over the speed of light in liquid. So refractive index 4 over 3 will be in air as in vacuum. In air, that's the same thing as in vacuum. Vacuum, that's open space. That will be 3 times 10 to the power 8 all over in liquid. So let's say speed in liquid. So we cross multiply. And that will be what? 4 multiplied by the speed in liquid will be 3 multiplied by 3 times 10 raised to power 8. This will multiply by this. So, invariably, the speed of light in liquid will be 3 multiplied by will be 9 multiplied by 10 raised to power 8 divided by 4. Divided by this 4 now. So, as you do that now, what do we get? This will be 2.4 divided by 9 will be 2. So, you are left with 1. In 10 now, that will be 2 again, then 5 times 10 raised to power 8 meter per second. That's the speed of light in the liquid. That's the second one. I hope that is clear to you. I hope that is clear to everybody. Then we move to the third one.